So welcome everybody to this ENLIGHT RISE workshop on green AI. I'm Sébastien Bérard from the University of Bordeaux, and I am sort of your man orchestra during the event. I'll start for a few words of a technical introduction so that you can know how to interact with us. So this is a Zoom webinar, which is not exactly the same thing as a traditional plain Zoom meeting. Not be able to use your microphone or video. However, you can of course interact with us. If you look at the bottom of your screen, you will see something called Q&A, which is a feature that allows you to ask us and ask, of course, the speakers questions. We can answer through this, and if you have questions for speakers, we'll use your Q&A that you will ask during the presentation, and we'll tackle them at the end of the speakers' presentations. So Charlotte and Magali from University of Bordeaux will take care of that Q&A that we will address with speakers at dedicated times at the end of their speeches. Last thing, this webinar will be recorded and will be available on the ENLIGHT YouTube channel later on. And maybe I'll and then the workshop will start right away by an introduction by Margaretha Andersson. I will then now introduce Margaretha. So Margaretha is Associate Professor in Chemistry and has an academic career in materials science and engineering. She has broad experience in research infrastructure as user, manager, policymaker, and in governance, including industrial liaisons at local, national, and international levels. At present, she is director of the Uppsala University Culture and Heritage Core Facility and coordinator of the Uppsala University EOSC team. Margaretha, the floor is yours.
Thank you very much, Sébastien. And on behalf of the ENLIGHT Alliance, who is the responsible organization for this webinar, I would welcome you all to this Green AI webinar. Before we go into the program, I would like to say a few words about the context. A few years ago, the European Commission launched a new initiative to put more sustainable effort into European collaboration. The initiative was called European Universities. And one of those initiatives is this ENLIGHT Alliance, who's the responsible sender for this webinar. As you can see, it's an alliance of 9 comprehensive research universities, and we are representing 9 different European countries. We have approximately 300,000 students per year, and we serve more than 5.5 million inhabitants all over Europe. We also have a strong commitment to social responsibility, and the alliance is addressing social challenges or societal challenges within Europe and the wider world. Next slide, please. Since this ENLIGHT Alliance is a joint funding initiative from the Erasmus Plus program and the Horizon 2020 program, we also have one focus on science with and for society. And ENLIGHT RISE is such an initiative where we are focusing on different activities around open science, the sharing and connection with digital research infrastructure. We also have activities related to civil society, innovation, and early career development. Next slide, please. Why green AI then? The scope for today. when the use of green AI has been identified as an important tool for a competitive and sustainable Europe. During the upcoming year, the presidency of the European Commission, Sweden, will host a meeting with decision makers in order to set out for a European ecosystem involving AI as a tool for the sustainable society. And then we come to the reason why digital research infrastructure is so important, because in order to actually perform artificial intelligence and do research with digital means, there are the need for infrastructure and resources to collect, to store, to process, and to share data. And in order to make digital means be a strong impact on the societal transition, the ENLIGHT Alliance also work in these areas. And since the sustainable society is really a focus area for the ENLIGHT Alliance, we also will focus on how we can do big impact and how we can actually make things happen in this area. And that will also be the focus of the program for today. Next slide, please. We are now waiting to lose an interesting set of speakers with a broad experience in different areas with importance of digital and green AI. We will of course have a short break later on when we listen to all the speakers, and before we go to an end, we will also have a short we will end with a panel discussion about how we can develop green AI and how we can make things happening. So with these introducing words, I will go into the program where I will welcome Professor Edward Curry from University of Galway. Professor Curry is a professor in data science and director of the ENLIGHT Research Center for Data Analytics and Data Science at the Institute of the University of Galway. And he will speak around can Europe facilitate the development of a more responsible AI? Welcome, Professor Curry. The screen is yours.
Thank you very much, Professor Andersson. I think, Sebastian, you need to let me share my video.
Yep.
No. And can you see the slides okay?
Yes, that's fine.
Fantastic.
Great.
Well, first of all, thank you so much for the invitation. Like the ENLIGHT project has been such a breath of fresh air in terms of the exciting activities that you're doing. And I've been quite jealous looking at all of my colleagues participating in many of the ENLIGHT activities. So when I saw this workshop on green AI, I reached out to Sebastian here and the organizers, and I was delighted that they invited me along to speak. One of the challenges that you have when as we all have, is trying to find the time for interesting topics. So when they propose this idea of responsible AI, it's not something that I talk about quite a bit myself, because I'm more on the data side, and I look at using AI to kind of drive decisions and kind of change. But it really kind of caught my interest. And then when I saw the notion of green AI and sustainability, those are definitely topics that I work in. And what I wanted to do is I wanted to think about, well, how do we set the scene for this? Because we're kind of at the start of a journey here. We have this technology that's rapidly developing AI, and it has some quite significant ramifications for our society. And what we're starting to see now is some of those early signs of how AI has positive and negative effects, and some of the challenges that we're going to have, and also the opportunities as well. So I think there's many questions that we have about AI, and there's not an awful lot of answers that we have there yet, and that makes it perfect for a group like this, where we have a collection of multidisciplinary researchers coming together, looking to explore a topic, understanding what the future could hold and how we can try to shape that. So today's talk, I was working on this last night. I was coming back from Brussels, from an event from the European Commission called SEMIC, which is about semantic interoperability of data and creating an interoperable Europe. And I was trying to figure out, well, how do we kind of set the scene here? And what I've identified as some of the kind of topics that I think are important for AI and for our digital transition. And the questions that I'm going to pose here, I don't really have answers to most of them, but I think they're very interesting for us to consider so that we can set the scene and understand what are the challenges that we have. And if we want to develop this notion of responsible AI, green AI, sustainable AI, what does that mean? What's the kind of state of play? So it's a little bit of a set the scene and hopefully leave you with more questions than answers at the end. So I want to kind of start off with just thinking about AI and trust that we have in AI decision-making capabilities. I'm going to give a couple of examples. Some of these you might have seen before, some of them might be new to you, but I think they're all quite relevant from the point of view of understanding what the state of play is in AI, some of the key elements for it. And this first one here is actually from one of the large American companies, Amazon, where they were using AI to try to help them or to see if they could actually use AI to help them to recruit better within their organizations. So this was a project that was done internally, and what they actually found is that when they looked at the people that were successful in their organizations and they built their AI to be able to analyze, well, can we identify more of those people? What they actually ended up creating was a tool that actually had a bias against women. So Amazon systems, by analyzing their data, what they basically found, what it taught itself, what the AI learned was that male candidates were preferable, and it penalized resumes of people that had terms such as like a woman's chess club champion. And the reason for this was because of the actual data that they analyzed. They actually looked at the data from the people that are employed by Amazon, and what you suddenly find is that, well, actually, these large companies employ primarily male candidates and primarily within technical roles as well. So the actual bias that existed there was not in the AI, but rather in the data that they were using to feed the AI. And you can see the kind of consequences that you get from this. Now, Amazon never claimed to never actually use this in any hiring decisions. It was kind of like a research project, but it does show the danger of trusting an AI to make a decision when the underlying data and the assumptions of that underlying data have flaws in it. So this is quite interesting. Another example that I think most of us probably are familiar with when we start looking at these smart home assistants or these speech recognition technologies that we have, whether it's Siri or Alexa or any of those tools. And again, these are trained from an AI perspective on using the data that has been gathered there. And there was a survey or an investigation done by the New York Times that actually identified that these technologies from all of the different vendors that do it actually performed worse if you were actually coming from an ethnic minority in the US. So if you were actually African American in the US, the actual speech recognition technology performed worse for you, where if you were white, you actually had much better performance there as well. And again, that's a representation in the data that was used to train that speech recognition technology, because it was biased towards having more white users and having more Black users in there. Again, the AI itself will basically react to the type of data training that's given to it. And then finally, a very, very up-to-date example. This is what all of the computer scientists and AI researchers are very excited about at the moment. It's called a GPT, which is a large language model. And literally a few days ago, they released what they called ChatGPT, which is basically an AI chatbot, and people are getting very, very excited about this AI chatbot. And this is an article from last week, or maybe even early this week, from The Guardian, that talks about the game-changing potential that this ChatGPT has. But very interestingly is when people start putting in different questions to it, and this is a tweet that I found on Twitter. I'm still on Twitter at the moment, and you can see it's a very simple kind of riddle that kind of identifies unconscious biases that might exist in us. And I'm sure you've seen this before, where a father and his son are in a car accident. The father dies at the scene and the son is rushed to hospital. At the hospital, the surgeon looks at the boy and says, "I can't operate on this boy. He is my son. How can this be?" And we know that this example identifies an unconscious bias in people where they assume that because the person is a surgeon, they must be a male. Well, in fact, the answer to this is that the surgeon was the mother of the son. But you can see here in the latest technologies that we have, and literally a hot off the press chatbot from AI, the AI itself has fallen into that unconscious bias as well, assuming that the surgeon must be male. So these are really important things, because this is the state of the art of AI decision making. And when we think of the context that we have today about responsible AI, these three examples identify significant challenges that we have within AI. It's very exciting when I actually look at this from a computer science point of view and actually figure out that it managed to reason this far. But it's also disappointing that it has that bias in there. But I think the technology is very exciting, but there's significant challenges with this, and we really need to look at how we build these technologies to understand how do we truly create AI that we can trust, which is the first step, and then the next step I think will be to look at is it a responsible AI as well. So what is responsible AI? So this is definitely, I would say, a new term. Is it trustworthy AI? Is it sustainable AI? I think this is very much the conversation that's going to take place within ENLIGHT, which I think is very interesting, and I think it's a very pertinent topic for us to look at the moment. What I did do is I popped into Google on my bus home last night to figure out, well, who else is starting to look at this? And very interestingly, when I popped in responsible AI, some of the companies that came up straight away were Accenture. Accenture had a definition here. Responsible AI is the practice of designing, developing, and deploying AI with good intentions to empower employees, businesses, and fairly impact customers and societies, allowing customers to engender trust, which I think is quite important, and then scale AI with confidence. So it's a very broad definition of responsible AI. Here's another example then from Microsoft. And what I noticed is that those large tech companies, each of them actually had web pages talking about the responsibility of AI and how they're responsibly designing their systems. And I think that's very much a reaction or an evolution from looking at those examples that we had before, where we see the failings in AI, and the failings are very much coming because we're not considering the breadth of the data that we're using to train it, and we're not looking for things like bias and representation and fairness within that data. Now we're starting to see that this becomes important, and this is from Microsoft here. It's a nice example where they're looking at ethical and explainable and notions of fairness, inclusivity, accountability, transparency. This is quite nice, and it's very positive to see this. At the same time, the last example I gave you there from ChatGPT, it's literally a week old, and we can see some very clear biases that exist within that as well. So I think we're at the start of this journey. We're definitely not at the end of it. But this is a nice example kind of coming from the industry about how they're looking at responsible AI. But also I think what's really interesting to look at is the policy and the regulation that's starting to emerge in this place as well. And this is a document that was released by the White House in October, so hot off the presses, and it's a blueprint for an AI Bill of Rights, looking at what's important about creating automated systems that work for the American people. And just some of the kind of key things that they're actually looking at in this Bill of Rights is the notion of safe and efficient systems, looking at the algorithms, the discriminations that can exist in there and protecting against that. And again, those three examples that I gave were all examples of discrimination within the system, looking at the notion of data privacy and the importance of preserving individual and corporate data in that notice, giving, again, this idea of notice and explainability, and then human alternatives. Is there human consideration? Is there a human fallback option as well if the AI system fails to deliver the expected outcome? So this is very interesting when you start to look at the development of the technology and also the development of the regulation at the same time, understanding how do we regulate this technology. And for us as members of society, you know, our legislators, our regulators, our governments are very much there to help us define and decide the type of society that we want. And the role of AI is quite important there as well. So I'll move on to the notion then on the European side of AI. How is this kind of shaping up here? Well, the European Commission have been working at this for a long time, and they're developing what they call the AI Act, the European AI Act. And the key thing that they're looking at with the AI Act is, I would say there's two things of interest. The first thing is understanding the risk profiles that we have with our AI decision making. So if you have very, very minimal low-level risks, for example, identifying your friends maybe in a photograph or something like that, that's just personal to yourself and not shared, you know, the level of regulation that's required there is minimal. But as you start increasing the level of importance or the level of risk that's associated with your AI, for example, self-driving cars would be highly risky. the notion of using AI to help you identify candidates. Again, these are high-risk strategies or high-risk approaches. As you have these more high-risk scenarios, you need to have more regulation, you need to have more certainty about how that system is designed, and it needs to comply more with the AI Act and the safeguards that the Commission are trying to put in there. And when we look at this now from the European point of view, we'll see some of the articles here that are in the AI Act, and they're looking at things like risk management, data governance, the technical documentation of it, the record keeping of the AI system, the transparency of it, and providing that transparency information to the users so they can understand why a particular decision was made, the need for human oversight, accuracy, robustness, and finally cybersecurity. So you can see there's a lot of parallels between what the European regulators are trying to do and what the US regulators are trying to do, but very much about trying to give certainty, transparency, and fairness of decision making as well. And these are both acts that are in development. They're proposals, but from a technology point of view, it's very interesting to see the development of the regulation and the technology at the same time. So just to kind of flag as well that the Commission also recognizes that this is an area of development, and there's a lot of research and innovation taking place as well. And they themselves are funding significant amounts of research in this space as well. So I'd just like to highlight the European Partnership on AI, Data and Robotics. This is a public-private partnership between the European Commission and private industry and academia and research organizations that's coming together to try to tackle some of these challenges as well. And the partnership itself is developed around a framework, and I think the framework is really important in the context of the conversation that we're having here today as well. So the framework itself there you can see on the left, and the very first thing they talk about is this notion of European fundamental rights, principles, and values. So the absolute basics that we're looking at are very much what's kind of captured in that AI Act. And then looking at other items such as capturing value for business and society, and then looking at policy, regulation, certification, and standardization. These are very important things because they kind of set the scene, they set the operational parameters for how our AI systems will work. Then we see other parts of this partnership will look at things like the innovation system enablers, like skills and knowledge, the need for data, the need for experimentation and deployment. And then finally, at the bottom of the framework, you can see the technologies that need to be developed around this as well. But what I think is most interesting about this partnership is the framing that's required for these AI, data, and robotic systems to be developed and deployed and designed, and for European fundamental rights, principles, and values to be at the heart of that. And as a technologist, as a computer scientist, this is a very different way of looking at the world as well. So I think that really creates challenges for us to educate our computer scientists, but also for us to start building teams from multidisciplinary backgrounds and cross-disciplinary teams, where we bring this expertise from different parts of the organization or even different disciplines together to be able to create these systems. It's not just going to be a technology solution here. So overall, though, the notion of this partnership is to boost the adoption of AI in Europe, and in the April edition of Communications of the ACM, I have an article in there with some other colleagues that are involved in this partnership that just kind of identifies this. So if people want to learn more about it, they can find out more there as well. So the next question I'd like to talk about is data and the importance of data for AI. So this is very much a topic that's kind of close to my heart and something that's very important to me. And it really is kind of key to a lot of the work here that we're doing in the University of Galway within our Insight Centre for Data Analytics and in the European projects that we're involved in as well. What I'd like to do here is to think a little bit about where we are in the data world. And this is a quote from one of my favorite authors. It's a person called William Gibson. If you're not familiar with Gibson's work, he came up with Neuromancer, which is a very famous book. And when you look at maybe films like The Matrix, a lot of the ideas that kind of came there are kind of credited with him, this notion of cyberspace, a cyber world. So very much a kind of a futurist in his writings. And he was interviewed on a radio program probably 25 years ago at this stage, and they talked to him about the future and what did he think the future would be, and he had a kind of an off-the-cuff remark where he said that the future is already here, it's just not evenly distributed. And I think I first heard this in around probably 1989, 1990, and to me this was very much about the opportunity that we have to be able to create our own future, and the idea that there are people there, and individuals can create our future, and the startup mentality of technology, that kind of promise about it. But as I've gotten older, I think there's deeper meanings to this quote as well. The idea that the future is already here, it's just not evenly distributed, so that yes, somebody else lives in the future, or somebody else gets to define what your future is. So this notion of agency and how can you create your future, and are you able to create your future? Will the future be created here in Europe, or will it be created in another part of the world? We'll be told what that future is. So I think there's some kind of deep thoughts there. But I want to bring that back to the notion of data, because data is a very interesting commodity at the moment. This is an article from actually the cover of the Economist from a couple of years ago, where they talk about potentially data being the most valuable resource in the world, and very much looking at the notion that we've got these large data companies that aggregate data, and we all recognize the importance of data and to be able to access and to use that data. But this is the Economist. You're talking about the notion of competition, and do we have fair access to that data? Is there a barrier that could potentially be done there from an innovation point of view? And I think that's quite important, because if there's a barrier to entry to be able to use AI, which is the need to have large quantities of high quality, unbiased, representative data in order to be able to build these systems, well, then who has access to that? And can that only be done by very, very large organizations, global organizations? What about an individual person that wants to do that? What about small and medium-sized enterprises? What about a university that wants to do that? Are we actually excluded from this future? Are we excluded from being able to use AI to be able to do that? And this really is a key challenge. And when we think about it, from our society, if I'm going to keep going with the old metaphor, which I think is fitting when we start talking about green AI and the challenges for that. I think we're really good as a society at generating and analyzing data. So we have lots of ways of being able to analyze the world. We have now IoT devices being deployed all over the world. We all have our phones. Our phones are creating massive amounts of data about our society that we can use and look at. I think we're really good actually using AI to actually make decisions, particularly around analyzing data to be able to optimize processes, whether they're in businesses, in organizations, and now we're starting to use it more and more within our society to be able to make decisions. I think we're making great progress there, but I think the big challenge that we have at the moment is this ability to be able to take the data from where it's created and to be able to move it to where we need to be able to make the decisions. What we're actually lacking is a platform, is this logistics that connects the data creation to the point of decision making. And this is what we don't have. And this is actually really one of the key competitive advantages that those large global organizations have, is the ability to kind of collect data, to be able to move it where they need to be able to make decisions. And so this is a key challenge for us to be able to figure out, how do we improve this logistics to make it easier for data to flow and to move around to where it's needed. So for me, the way I think about this is that we need to kind of think about this from a public digital infrastructure point of view. I think as a society, we need to think beyond just expecting the private sector to provide this, but to think about, could this also be provided by our public sectors? Could it be provided by government as a shared societal service, in the same way that we have shared societal services for things like water, for sanitation, for healthcare, for roads? Why wouldn't we have a shared societal digital infrastructure as well? Why don't we have data platforms that help us move this, that are owned by the public, and are used towards public good as well, but also for private means as well? What's interesting about this is that the European Commission seem to also think that there's an opportunity here as well. And for many of our French colleagues on the call, you'll be very familiar with Thierry Breton. He is the Commissioner for the Internal Market. And he's very much talking about the need for a European approach to data sharing. How do we ensure that we have trust in our ability to be able to share data, that we improve the flowing of data between different organizations within Europe? And ultimately, how do we create ourselves as a kind of a single market for data? How do we make it easy for data to be able to move in a trusted way, in a way that's compliant with regulation and privacy, between any part of Europe? And potentially, if we do this allows us to become a world leader in the area of data sharing and data flow. The Commission have come up with the European Data Strategy about 2 years ago, and one of the key things that they want to do is to create this notion of common European data spaces. So how do we create areas how do we create spaces of technical infrastructure that allow us to be able to share data in areas like health, manufacturing, culture, mobility. And what's important here is that by having these spaces where organizations and individuals can come together to share their data, well, then we can use that data collectively to also build our AI systems, because we basically are replacing that large multinational organization that can aggregate data with a societal scale data infrastructure that allows lots of actors to come together to share their data in a trusted environment that's supported by data governance and the necessary regulations. And then using that large scale data, we can ensure that it's representative, that it's fair, that it's transparent, and then we can start to build AI systems on top of those data spaces. So this is quite forward looking, I would say, from the point of view of the Commission. And this is very much an ongoing work. Interestingly, people often ask me, particularly in Ireland, would we actually trust our public sector or our government to be able to actually deliver on this type of a vision? And within COVID, very interestingly here in Ireland and in many other parts of Europe as well, but within Ireland, we managed to create our COVID-19 data hub within a matter of weeks. And in the first 6 months of it in operation, the data hub had over 100 million downloads. And what's really interesting about that is that we managed to connect things like our COVID tracker app that again was created very quickly, but that was verified, that was done in a transparent way, and basically allowed individuals to be able to report to the data hub and then to be able to share that information anonymously. And within the first kind of six months of this hub being live, there was over 100 million downloads of the data set from it. And that's quite interesting, because Ireland has a population of about 5 million people. So there was an awful lot of interest in this, a lot of people pulling down that data to be able to see it and use it. So it is possible, but where there's a desire and a need, I think it's very, very feasible for the public sector to be able to create digital infrastructures and to be able to do that at scale. And to be able to achieve that, then what we have for the Commission is the Data Space Support Centre. So this is a project that's been funded by the European Commission to actually implement that vision of these common European data spaces. And here at the University of Galway, through our Insight Centre for Data Analytics, we're a part of that. But it's also bringing together kind of some key organizations from across Europe. So organizations like Gaia X, BDVA, International Data Spaces Association, and then some kind of key RTOs like TNO, VTT, Fraunhofer, etc. So this is very much, I would say, that the start of a journey over the next kind of decade to build these common European data spaces. And hopefully that allows us in Europe to ensure that people have access to data, access to high quality data, and then they can use that to build and kind of drive their AI systems. So the next thing I'd like to talk very briefly about is the notion of bias in data, because bias is quite interesting. And again, the examples that we had at the start of this very much kind of identified the challenges around bias and how we have to tackle that. The reason that we have bias, people always wonder this is, well, do we have bias in the data, or does the data just reflect us as either organizations, as individuals, and maybe sometimes shows the inequalities that might exist there, or just reflects the state of play that's there? And that's very much true. And when we look at the complexity of data that we have, what we see is that there's going to be more and more challenges around this. So the problem that we kind of have is that ultimately data is created in a decentralized way. It's created by different people that have different perspectives. They have different ways of conceptualizing the world. Many of those, the majority of those, I'd say, are valid from that person's perspective, but it does create things like ambiguity, vagueness, and inconsistencies. And these are difficult things to challenge and difficult things to manage as well, because while you might have these inconsistencies in the data, you might think that that's something wrong with the data, but in fact, maybe that's just, reflecting or mirroring an inconsistency that exists in the real world. So the challenge isn't about the data, the challenge is about the real world and the society that we have. So it actually brings us to more deeper level notions. And this kind of also moves into the world of subjectivity as well. So again, computer scientists, engineers, you're always kind of thinking things are very objective, things are black and white, they're yes and no. But the reality is, as we look at the data that's created about our world, created by users and on users, what we actually see is that there's an awful lot more subjectivity out there. There's a quote there from Orwell that talks about the concept of objective truth is fading out of the world. I wouldn't quite go that far, but when you start looking at things like social media and the data that's created there, I think we'd all agree that there's definitely a lot of subjectivity there, lots of different perspectives. Lots of those perspectives are valid, and sometimes they're in conflict with one another as well. So we have to recognize that subjectivity and to build our systems to be able to work with that. That really is a very significant challenge. And just a simple example of that is the notion of, if you look at like hotel reviews or restaurant reviews, the notions of how do we build queries and how do we build systems that allow us to be able to understand things like, well, I want to find a reasonably priced hotel in London. Well, reasonably priced if you're a student, and reasonably priced if you're a business executive, are quite different things. That reasonableness is very much, let's say, subjective to the individual and the context of that individual. And that becomes quite important, because when we start looking at bias and we start looking at the challenges that exist around subjectivity, we have to start looking at the context. And AI needs to look beyond just the data itself to start looking at a broader context for that. And I suppose positively, there are techniques we can look for that. So for the more computer science people in the audience, the notion of bringing together kind of neural networks, which are all about the data and analyzing that statistically to drive AI, but also things then like formal knowledge, things like knowledge graphs, where we have expert knowledge, where we have logic and rules that basically help us understand the world and how it works. So I would say the latest techniques in the area of AI are trying to balance both of these worlds together. How do you balance the data-driven world that analyzes all the CVs with the knowledge graph and the expert knowledge that explains to you that a woman's chess club champion is probably a person you definitely need to hire and bring into your team, because that's a high level of performance, high level of intellectual ability. But there's other examples of where this can be done as well. So this is some work done by a student of mine, Jalid Khan, that looks at visual reasoning. So again, we've got examples here of where an AI is taking a look at a picture, and the AI can identify different things within the street and try to understand what it is. AIs themselves are not that clever. I think the simple example here is that the one in the middle here, where we have somebody who, when we look at it, they're obviously drowning and they need help. But if you had an AI system that had a camera here, what they're identifying are things like, well, there's arms, we can see oceans. How do we figure out, is the person here just swimming, or actually are they in need of assistance? Do we need to identify somebody, notify a lifesaver to be able to help this person? And by looking at the data analysis, the computer vision models from AI, they can help us identify these arms. But what we also need is to figure out, from a logic point of view, is this person swimming, or are they in fact in need of assistance? And by bringing together these knowledge graphs together with the statistical approaches from deep learning, we're able to build systems that understand that context, that have that broader perspective than just the data that they're looking at, and are able to reason better about what's needed and being able to identify that this person is in fact drowning as opposed to just swimming. So that's an opportunity for us, but this is very, very early stages in terms of development as well. So moving quickly on to the kind of focus of the sustainability that we have for AI. Well, can AI develop sustainable systems? Well, I think they definitely can, and there'll be more detail on this later on today. But I thought there was a very interesting report, a paper in Nature 2 years ago that looked at our UN Sustainable Development Goals and tried to identify the different areas where AI could help improve that, and where AI may be inhibited by that as well. What we can see here is overall, there's a lot of opportunity for AI to be able to improve sustainable development and the triple bottom line that we have. We can also look at how AI can improve our smart environments, whether it's buildings, agriculture, or energy, smart cities, and water environments. And there's been a lot of work that's actually been able to identify that. One of the interesting things there is the need to be able to bring together the digitalization part of the world, but also start looking at things like human-computer interaction as well. How do you take the data, but then put it into a context where a user is able to use that at the appropriate time to make positive decisions about how they want to be able to build and create, how they make positive decisions around sustainability and energy usage. We have some examples of where we've done that ourselves here within the Institute, where we've deployed AI data-driven systems within airports, offices, schools, and been able to target different types of groups with different types of information at the appropriate time to be able to improve their decision making. And by doing that, we've actually been able to see a number of improvements in terms of the environmental impact, reducing the CO2 footprint, reducing the amount of water usage, and also importantly, having economic improvements to that as well. So I think there's a lot of opportunity there, and hopefully in our next talk, we'll see an awful lot more detail about that as well. But is there an environmental cost to AI? And the answer there is actually, unfortunately, yes, there is quite a significant one. The example I gave earlier on about GPT, these are the hot topic in AI today. They're very much looking at these large language models. The idea here is you analyze lots of text, you create this large language model, and then from that, you're able to have a numeric representation of the knowledge and the information that's in this text. So GPT is one of those, BERT is another one. These are, I would say, state-of-the-art approaches in the area of computational linguistics. The challenge with this is that these models are increasing in size at a drastic rate. So this is an example of just over the last 4 years. And on the left here, you can basically see these earlier models, and we're basically seeing an exponential growth where the number of parameters have gone from 94 million parameters in a model to the latest ones that have been released that have 530 billion parameters in a model. So exponential growth in the size and complexity of these models. The challenge with this is that these models themselves take a lot of computing resources to be able to develop and to be able to train, and that has a substantial potential carbon footprint as well. So here's an example of a model. This was a study done in 2019, so at the early part of this. And what you can see here is that, you know, training an AI model, large scale language model, can actually have up to 300 times the cost of a flight for a passenger from New York to San Francisco. So that there's a very, very significant carbon footprint associated with these models. Now, I'm sure a lot of the companies would say, well, we're using renewable energy to do this, but there still is significant amount of energy that's been used. So it becomes important for us to think about AI and think about how do we create sustainable AI. So again, having a look on the web yesterday to understand, well, what's the state of play here? Are people thinking about sustainable AI? And there is. So this is an example coming more from the practitioner community that's identifying how do we create smaller models? How do we have different deployment strategies to reduce the energy consumption of AI? Is our AI work carbon and energy aware and efficient? Also, a very nice article from last year that talks about sustainable AI and the idea of AI for sustainability and the sustainability of AI. This is a very, very nice article. I have to say it's an article I wish I wrote myself. It's very, very nicely done, and I would recommend people to take a look at that. But the important thing there is that we see sustainable AI and potentially responsible AI as kind of being two sides of the same coin. The AI has the opportunity to reduce emissions. We also need to make sure that the AI itself does not have significant emissions associated with that as well. And a good example of that, again, one of my students here, Felipe Pontius, is looking at edge AI. And this is an example here where we have an edge-based camera that has an AI processing node on it. And we're trying to identify safety conditions on a construction site. So in this example here, we're making sure that all our people actually have all the appropriate safety gear. So are they wearing their helmets? Are they wearing their high-vis vests? And we can see here an example where one of the workers is not wearing that high-vis vest. What Felipe is looking at is this notion of a trade-off between the accuracy of the AI, the speed of the AI, and the amount of energy that it uses. So the more accuracy that you want and the faster you want it to be, the more it costs energy. The more you're willing to trade off that accuracy and speed, the more you can actually reduce the energy that's associated with it. So these are, again, interesting things to explore. And depending on the type of decision that you're making, you may actually be able to trade off the accuracy for that. But if it's an important decision around health and safety, accuracy is not something that can be traded off then as well. So these are important considerations to take into account. So that is it for me. Hopefully I've kind of stimulated some thought. I definitely haven't answered most of these questions that we've talked about because I think we're very much at that beginning stages of this kind of digital transformation that will be driven by AI. And I think AI can definitely enable solutions to the challenges that we have in our society, but we have significant challenges in being able to deliver on that promise. And it's very much going to require a multidisciplinary approach that brings together computer scientists, people from information systems, people from humanities, ethicists, regulators, multidisciplinary teams that really help us understand the complexity of the problem and fundamentally the complexity of the society that we want to create, because ultimately AI really is reflecting the society that we want to have, the types of decisions that we want to make, and ensuring that we build systems that reflect the type of society that we want to create together. And that's it for me. Thank you very much.
Thank you so much, Edward, for this really enlightening talk, which really shows us that the more pervasive AI is becoming, the more thinking of what a responsible AI is really what society we want to live in a way. We have a few minutes for questions. Don't be shy for one question, everybody. If I can start it, because the first question is always the most difficult one. This question of the ethics behind AI decisions, the societal impact of AI, should be some discussion with the wider society taking place. How do you think this could happen for things that are for a good deal of it difficult to grasp? For the wider society, how do you think, do you have the elements, ideas of how could efficient democratic discussions to make decisions about AI, where they should take place or how they should take place?
Yeah, look, I think that's a fantastic question. And it's a question I don't have an answer to. I have ideas for what we might try to do there. And some of those are taking place as well. Like ethics is so first of all, ethics itself is its own field, and there's experts there. And the first thing we need to do is to get ethicists in the room to help us answer that question. I think it's really important that we look at this from a point of view of not just about trying to regulate what AI is, but to ask what kind of society do we want, and then how is AI as a tool helping us to do that. So I think the fundamental thing there is not a technology question, but it's a societal question for ourselves. So it's a case of how do we engage our citizens, the people in our society, to ask that question, to kind of co-create and to design the type of society that we want. That's the first step. And we do have, when we look at this from the political sphere, there are different forms that are used for that. So, for example, here in Ireland, we had a recent form from our National Science Agency to ask what kind of research should we do in Ireland. So they asked all of the citizens forum to be able to kind of collect that information and to process. I think that's the type of engagement that we need. We need this ongoing dialogue within our society that engages everybody to ask what kind of society do we want to create. And when we start to define that, then we can start figuring out, well, how do we bring in AI as a tool to help us enable some of those scenarios? And then as we're designing that AI, are we sure that we're doing it in a way that is compliant with our values and what we expect of a system that we would trust? So it goes back to, good solid engineering, good solid regulation to say this is our expectations for these types of technologies and how they perform. But I think the more important question there is, what's the society that we want to create together? And one positive thing I would say is that when you look at the European Commission and the notion, and the European Union, the notion of the values, the fundamental rights that we have as Europeans, not a lot of people are aware of those. I think if you ask the show of hands here, do people know what fundamental European values are? There's actually a webpage, there's a list. It's part of treaties that the Commission have created within the European Union. I think we need to improve the awareness of that so that people understand what it means to be a European, what we respect and what we expect of each other within our society.
Thank you so much, Edward. That is definitely a take-home question for me as a university librarian, because I really think, listening to you, that university libraries have a great role to play in that. Absolutely.
And getting the computer scientists to walk over to the humanities section to start pointing out where the books on ethics are as well. I think we need people to explore the library more so we have broader perspectives. Couldn't agree more.
Anybody want another question? Oh, yes. So Edward Kleinpeter, a question from Edward Kleinpeter. I'm reading it aloud. Regarding sustainable AI, I have questions about the so-called rebound effect, and namely the means at our disposal to prevent it. In a nutshell, if we somehow become able to design less voracious AI systems in terms of resources, which is, as Edward said, by better fitting AI systems to their intended accuracy, what would prevent the today unavoidable response of the liberal market that would definitely conclude that they can provide more AI systems to their customers?
That's a good question. I'm not sure there's a problem with more systems as long as they're appropriate. To me, the biggest challenge in this is the notion of agency, which is not even it's not a notion from computer science at all. But it becomes, what decision are you making? What's the level of risk we have with that decision? And why do we want an AI to actually make that decision for us? And I think a really good example of this would be if you look at the Boeing and the 737 MAX. And you know, Boeing knew how to build an aircraft. They built very, very high quality aircrafts for many, many years. But then in a design process that has many, many factors in it, they created a system where they had a single point of failure, and then they had a system that overrode the agency of the pilot that says, no, the pilot is wrong and I'm going to do this. So the issue there is, how do you ensure that when you're using AI, you're using it in the appropriate place and that you're giving it the correct level of agency? You don't want to give it too much agency, and should it override human agency at any point? And if it is overriding human agency, you need to have a really, really, really good understanding of that. And the humans involved in that need to understand what's happening as well. So I think, to me, it's more about the design. It's not about having too much AI or too little. It's about having it appropriate and having the people who interact with it understanding what role it has and what level of agency it has within the decision-making process. I see another question here. So
Thank you, Edward. Actually, we're a bit behind schedule. If all people that have asked questions, I'm sure some talks that are coming later, right afterwards, actually, will provide some elements of answers. And of course, this is an announcement to all panelists here. Don't hesitate to I think you have rights to answer directly in the Q&A line. So don't hesitate to answer those questions using Q&A, because everyone will be able to see your answers. So don't hesitate. Thanks again so much, Edward. This was really, really stimulating. And then I'll share my screen, and sorry for this. And I will then move to the second part of the workshop, with two conferences from researchers about the question of green AI. And the last questions was an excellent transition to Aurélie Bugeau's talk. Please note that we will take questions at the end of both discussions, since there will be two conferences, one after the other, Aurélie and Adrien. So I'll just quickly introduce Aurélie, who will give us a conference called A Few Elements About Environmental Impacts of AI for Environments. Aurélie Bugeau is a full professor in computer science at the University of Bordeaux, and a junior member of the IUF, French Higher Education Institute. Since 2010, she is a member of the Image and Sound Department of the Computer Science Research Laboratory of Bordeaux, the LABRI. Her research focuses on image processing and analysis, and in particular on image restoration. She is also now studying the environmental impacts of digital technology, and in particular AI, And that is the topic that she is going to talk to us about now. Aurélie, the floor is yours.
Yes, thank you for this introduction. Share my slides. Do you see them well?
Yes, thank you.
Great, great.
Okay, thank you. So indeed, I'm going to discuss about environmental impacts of AI for environment and in particular, how to measure those impacts. So this is somehow a transition with the end of the previous talk. I will go a bit further with what was said in previous talk. So this is a joint work with colleagues from France and in particular 3 colleagues. We are the 4 of us are member of the EcoInfo research group, which is a nice national group that focuses on environmental impact of digital systems. So in all my talk and in what we have talked, we will probably mostly talk today. We kind of do an abuse of language because we are focusing mostly on small part of AI. Where at least in my talk, I'm focusing more on machine learning and more precisely deep learning system that work using by training some huge models on data. So it's not all AI, it's really a small part of it. And why am I interested in their impacts is because, as you may know, AI has been growing a lot lately, this past year. So you see here, it was in 2017, so maybe it's much higher now, but the number of scientific publications and patents that are exploding. So it's worth considering, well, what does this have to do anything with environment, and should we take care or not on the impacts on the environment? So regarding AI and environment, there are somehow two communities more or less separated. The first one is AI for green, which considers AI as a tool for sustainable development. We've seen that in previous talk also. And the second one is green AI, which goal is to measure and try to reduce AI impacts. I'm going to go quickly on the first one and mostly focus on the second one, actually. So AI for green. So this is a paper that was just mentioned by a colleague in previous talk from Vincent that indeed has studied for more than 400 differences and showed that AI can be used to tackle many sustainable development goals as defined by the United Nations, but also that it can have some negative impacts for some of those goals. But it's mostly positive when you look at this paper. Well, there are some warnings at the end of the paper. I will not, I can come back to this in further discussion if you need, but I will go into another paper that's more focused on tackling climate change. So this other paper studied more than 800 references and classified them in 13 domains related to sustainable development and climate change, tackling climate change. Around so how AI can help driving electrical systems, help with transport industry, climate change predictions, societal adaptation, smart buildings, smart cities, and how to help with land use and farmland and so on. And for all these domains, the authors did a work to try to say which technology more precise technology can be used for each of the sub-goals for all these domains. So globally, these papers, the other one also from Vincent, all those work show that AI can be of great help for for sustainable development, and is a powerful tool to tackle many of our today problems and future problems also with environment. So it's mostly a techno-optimist perspective, but in both papers, and in this one particularly, there are some uncertain impacts and Jevons paradox. So those are also the rebound effects that were discussed, that were just asked by someone just before. They are mentioned, those rebound effects, indeed. For instance, as they say in this paper, regarding transportation, autonomous vehicles, developing autonomous vehicles that are said that they will consume less, so produce less greenhouse gases and so on. Those vehicles could cause people to drive far more. This is a very well-known rebound effects regarding transportation. In industry, it is worth noting that greater efficiency may increase the production of goods and thus increase greenhouse gases emissions. Regarding farms and forests, making forestry more efficient can have a negative effect by increasing the amount of wood harvested. So there are rebound effects mentioned in this paper, even if globally it is said that AI can help tackle climate change. So they are proposing some recommendation. So mostly what they say is that for many projects should be preceded by a system impact analysis before developing the system. There should be an analysis beforehand, that to make sure that they will indeed decrease greenhouse gas emissions when they are put to the, let's say, I don't have all the English vocabulary sometimes, but when they are deployed more globally to the society. And the other part that the other recommendation is also to be careful to not end up in the to be locked in a service that public policy must meet industries priorities, to be careful to not be locked in a service that would increase in the end greenhouse gases emissions. The question is then, how can you measure those impacts? How can we do a previous analysis to the system? Can we do them? And so this is what we have been also trying to look in the literature with my colleagues. How do we measure those impacts? So this is the other part, community. So when you do deep learning, what you can do, or machine learning indeed also, what you can do is when you train your system on data, you can count the number of basic operations. This is just algorithmic complexity. You can look if your algorithm is complex. So you can count these operations and then say that they reflect the amount of calculations that can give you a hint on how impactful is your system. This number of basic operations partially correlated with execution time and is hardware independent. So it's a great measure independently on the system you will run your algorithm. But unfortunately, it has been shown that it's not completely correlated to energy consumption. For instance, you can see here that some very famous neural networks can consume less energy, even if they have more operations, and some others that are not as well implemented or not on the right hardware can consume more with less operations. So some of the person have proposed some tools to measure more precisely the energy use by looking at the real usage when measure it consumes, how much energy it uses. So this is done by using at the memory, the CPUs, the GPUs energy. I won't go into technical detail too much. And by looking also at the power usage effectiveness of your data center. If you train big models in data centers, you need to be careful on which data center you train your model. In particular, data centers include climatization, transformers, generators, fuel tanks, and so on. And those external systems that are not only IT facilities can consume a lot. So this is looked by this PUE, and you want to try to have data centers with PUE as lower as possible, so as close as one as possible. So you can take that into account when you measure the impact of your neural network. So there have been some tools released. So for instance, this one, which is a website where you can look beforehand. So if I train a model for 10 hours on a GPU, you can say on which type, where you train it, the location, and so on. This, I will release approximately a certain number of greenhouse gases of CO2 emissions or a certain amount of energy. So this is a website. That can be improved, but it is a great tool to have an order of idea on your consumptions. And there are others that can be directly put into codes when you implement into Python libraries that are used to develop neural networks, and that can also give you how much you have been, how much energy you've used when training. So some tools now exist. There are several others. Won't go to an exhaustive list. And this is the result, the same papers that was just showed before regarding the analysis of 4 natural language processing models. So as it was said before, we can see that if models, so those models were trained just one, and you need to keep in mind that when we do train models, we do not train them well. Once we do experiments, we start training, we stop training. So it's not the complete cost of all these models, actually, that is showed here, but just the training of the biggest ones is equivalent to 1 round trip Paris-Hong Kong by plane. So it's not a big deal if you do that, you train your network and you share the weights with millions of researchers, millions of companies. And I mean, this means that, okay, you have had impact while training, but it's reused by a lot of people. So this is not such, let's say, such a big deal. It becomes a big deal if you do it for just from our fun, even if it's not for fun, but no. If we do it without thinking too much about it, and if we all start to do it, to train models like that, saying, yeah, we have a lot of data, let's train models without really knowing why, this can become a real problem. So the conclusions from the authors is that there is a need for cost, resource, and accuracy analysis when we do deep learning. That because of question of prices, if we train on Amazon servers or Microsoft ones or so, it's very expensive. So it's important that academics have public and shared computing resources, and to develop less consuming hardware and algorithms. This is also what will be discussed in the next talk, I think. The limits with all those tools is that they are monocriterion. We are only looking at CO2 emission, which is really a very small part of the global environmental problem today. There are many other impacts like ecotoxicity or resource depletions or biodiversity that maybe we should look at. So we are only considering this in those tools. And it's only a very small perimeter, which is electricity consumption during training only. It appears that we saw that with my colleague, that it seems that AI community is not well aware of existing works on impacts globally. But at the same time, this community makes a lot of promises regarding AI and its impacts. So for instance, some work says that, okay, it's like the Coumet law, that say the number of computations per joule energy will double every like 18 months. So it's okay. We'll improve so much our model that it's not a big deal, the energy today. And some others say that even that machine learning energy carbon footprint will shrink in the future, which is hard to believe when you think about the increases of AI. Well, this is an opinion, but there is not a lot of proof in history when you see development of technologies that can really make us believe this story of shrinking. So we wondered while looking at these limits, also we have wondered how to completely evaluate AI services dedicated to environment. And in fact, when we do evaluate environmental impacts of a product or service, the standard method is to use life cycle assessment. And so this is what we think should be done in the context of AI too. So just to explain, our life cycle assessment should work in AI, and in particular when we develop AI for environments. So if you look at the life cycle of all AI service, it looks like that. So you have data acquisition and production and data storage. Those steps use many equipments, different equipments, so computer data centers. Then you use those data to learn, train a model. So usually now a deep learning model. So again, we here use equipments. And then you do the testing phase and the deployment phase in a real life service, let's say. And here again, you use sensors like equipments, mobile, cameras, any sensors. And this is small parts usually of a biggest AI application, such as autonomous vehicles, smart building, or any other application. So in fact, right now, what I showed before, we're just looking at the energy consumption of the training phase. No one has been looking really at the impacts of all the other phases. And then, so we need to look at the impact of all the equipments. And to do that, we must do a life cycle analysis on all those equipments that are involved in the service. So a life cycle assessment must look at all the phases of the life cycle, from production, manufacturing, to the end of life of the equipment. And so there are methodologies that are made to look at that. And so you must look at what is used to realize those phases and the impacts that it has, such as greenhouse gas emissions, mineral or water depletion, and so on. And then one difficulty here is to find allocation procedures to determine the fraction of impacts attributed to the service. For instance, if you use a data center to train for, I don't know, let's say 12 hours, how much responsible are you on the manufacturing of this data center? So how do you allocate the impacts to the one that is using this service? So this is something really difficult and not tackled today. So in practice, when you develop a new AI solution, typically for environment, but it works for anything else actually, if you want to look at the potential benefits on environment, you need to compare the complete life cycle assessment of your new service and the life cycle of the assessment of the service it is replacing. This is a comparative LCA. And you need to look at that. So this is the D that is here. That means for D impacts, for many impacts, not only for CO2 emissions. Common pitfalls in such evaluation are that we only focus usually on one environmental criterion. We usually choose, yes, climate change or CO2 emissions. a very small perimeter, not all the life cycles. And we have tendency to generalize of contextual solution benefits to real, to generalize to complete impacts. Like if we have these impacts in the laboratory experiment, we multiply by a certain number, said this will be the impact in real life, which is not always the case. So parameters are not well settled from the start. And we clearly overlook third order effects, such as rebound effects. In fact, life cycle assessment is not really the right tool. Well, consequential life cycle assessment is not really the right tool to look at those third order effects, and so, which are also economical effects, society effects, and so on. And so to go quickly, we have looked at some of the papers that are cited reference in this one, and checked if they do actually analyze the impacts. So they promise that they will give solution to tackle climate change. So how much this promise is true? How do they evaluate actually their global impact? So we have looked at some domains with high leverage, at some references, all the references for these 4 domains actually, and we have looked if they mention environmental gain, if they mention, if they do a quantitative evaluation about energy, about other impacts, if they do a complete LCA, well, how can they say that they will help to tackle climate change? So we did this analysis, and well, we found no studies that follow, that do an evaluation that takes into account more than the use phase of AI. So even only for energy, actually. And if obviously no paper doing comparison of LCAs complete. So there is no paper, well, when we did this evaluation, at least we found no paper doing a complete analysis of the environmental impacts of the solution they propose. If we look more carefully, actually, a lot of them are hardly mentioning environmental gain, and very few of them start to do an evaluation of energy gain. So, for instance, if you look into smart building, yeah, I'm almost done. If you look into smart building, you could do, well, what is overlooked is life cycle impacts of the devices, as I said, only looking at training phase, but also what are the impacts of the smart solution on the design of the building? Do we need a new building to develop this, to deploy this AI solution, or is it applicable to all buildings? All those questions are hardly discussed. Are claimed energy gains reliable in the operational context or just in laboratory context? And human interactions, do we look at their rebound effects of counteracting behaviors? For instance, if you isolate more a building, well, it has been shown that people have tendency to increase the heat to have even more comfort. So do we take this human interaction, human behavior into account when we deploy our solutions? So just to conclude and open some discussion maybe. So what we observe is that current environmental evaluation of AI services is clearly underestimated and mostly focused on energy and greenhouse gas emissions. So we need to do LCAs, and we need to do it on multi-criteria. There are many unknowns in LCA that prevents us from doing them correctly, and mostly on the production manufacturing of GPU. We lack a lot of data regarding the impacts of the production of the hardwares. And so we need Europe, for instance, to lobby the companies to open a part of their data. We need everyone to lobby the companies to have impact on manufacturing of all this the hardware. We also need to take large structural changes into account as much as possible. I mean, if we propose a new system, how much will it change the life, the society, and how much this can have an impact? I believe it's our responsibility to think about it at least. And so the promises suggested by AI for Green must be evaluated and debated. I want to conclude with a positive note still, not saying that we must not do AI for Green. Obviously, we probably really need to do AI for Green, but we need to think about the impacts in a more global way, maybe, and we need tools to better measure the impacts. Thank you for your attention.
Thank you very much, Aurélie, for this stimulating talk and for showing us the problems at stake and well, the long road that remains to be done regarding the work that remains. The next conference, hello, Adrien. The next conference will be given by Adrien Vincent, and we'll tackle a related aspect of the same question with the subject of building green AI. So I'll just introduce you with a few words, Adrien. So Adrien Vincent defended his PhD on the use of innovative memory devices as artificial synapses in neuro-inspired electronics in 2017 at the University of Southern Paris Sud, France. After graduating, he was a postdoctoral researcher for 1 year in the group of Professor Dmitry Strukov at the University of California, Santa Barbara, USA, working on the statistical modeling of TiO2 memristors and their potential for analog dot product engines. He is now assistant professor at the Polytechnic Institute of Bordeaux and has joined the bioelectronics group at the AMS laboratory in Talence, France, where he has got involved in the H2020 EU project, ULPEC and RadioSpin, as well as the ANR AI chair, Green Artificial Intelligence. His current expertise areas are the modeling of memristive devices and system-level simulations of neuromorphic architectures. Adrien, the floor is yours.
Thank you very much for the introduction. I'm very glad, thank you also very much for the invitation to present the work that I'm doing at IMS with some collaborators on ideas that we could use related to the hardware that we use to perform artificial intelligence tasks in order to make them greener, let's say, okay? As we have already mentioned, so artificial intelligence is kind of pervasive nowadays, so you can find it in many areas in your life. And one of the milestones that we have had in the recent years regarding AI was, for example, the Go game between one of the best players in the world versus AlphaGo, which was an AI system developed by Google. And so Google did not provide the exact power consumption of that system at the time, but based on the publication related to AlphaGo, you can kind of get the rough estimate based on the amount of graphical processing unit, GPUs, and central processing unit, CPUs that they were using. And you end up in the area of 250 kilowatt. And as you can see on the picture, a game will last roughly around 2 hours. So if you combine those two numbers, you end up with the energy budget of kind of the equivalent of driving from Lille to Marseille in a small car, okay? So we have some issues with the energy here, and Google and the other major players in the field are well aware of that issue. So that's why, for example, Google developed specialized hardware chips to run AlphaGo in its second version, and they were able to decrease the power consumption down to around 10 kilowatts. But again, for 2-hour-long games, it means that it's equivalent to running your 100-watt microwave oven during 20 hours. Okay, so as we might imagine, that might be a real issue regarding, for example, embedded solutions, which means systems that are not connected to the power plug, like electric vehicle, drones, your smartphone, for example. But we're actually facing a more general issue that was already mentioned in the previous presentations regarding the information and communication technologies. So those technologies account for a total electric consumption that is a few % of the worldwide production. Okay, and it's expected to grow to follow the exponential growth of data that we produce, and the idea that we will be using more and more AI to process those data. Okay, so the exact values are to be taken with a grain of salt, but the idea is that I don't see how that number will be going down, and it means that AI, as we are doing it right now, might be not sustainable in the long term. So you could ask, why don't we simply build better processors? And the problem is that those systems are actually facing physical limits. So for example, regarding the thermal dissipation, it's been now a few decades actually that the frequency of processor is not increasing that much anymore, simply because we are dissipating the power densities that are the maximal values that we can dissipate with air cooling systems. So that's the first issue that we have. You cannot build faster processors nowadays, or not exponentially faster as we used to do. And another really big issue is related to the memory accesses. So conventional computers are based on what's called the von Neumann architecture, where you have the processor, which is crunching the numbers, and to get the numbers, it has to fetch them from the memory and to transfer the result back into the memory through what's called a bus. And nowadays, in application where you need to transfer back and forth a lot of data, you are facing what's called the von Neumann bottleneck. And a very important message here is that moving data is absolutely not free from the energy viewpoint. So that's what's represented here in that sketch coming from a very nice paper in the field. Basically, the idea is that they compared, for example, the energy budget that you need to fetch to retrieve data from the dynamic RAM of a computer in order to fetch it to the arithmetic and logic unit that will perform what's called the MAC operation, so multiply and accumulate operation, that is at the core of most of the neural network systems that we have nowadays. And when you look at that graph, basically, it means that you need hundreds of times more energy to fetch the data than you need to perform the actual computation. Okay, so that's a very important message here. And that's why we might want to look at alternative paradigms of computation, like, for example, biological brains, where you have neurons that are the processing units. And those neurons are connected together through what's called synapses, which are the memory point, and they are also able to change, which means to learn. So just to give you a few numbers about, for example, the human brains, the idea is that you have roughly 100 billions of neurons, and those neurons, each one of those neurons will be connected to, in average, between 1,000 and to 10,000 other neurons through synapses. Important features here is that those neurons are actually very low frequency, so they are working at tens of hertz rather than a few gigahertz like our computers. And the brain is it's still able to perform high-level tasks with very high energy efficiency, because your brain consumes roughly 20 watts. And that's because it's a massively parallel computing system, okay? You have the memory that is much closer to the processing units. And that's why you might want to take inspiration from that system in the context of memory-intensive applications. So just to dive a bit more in how an artificial neural network or deep neural network is built. So they are based on what's called the perceptron concept, which uses a formal definition of a biological neuron, where basically what a neuron does is that it accumulates inputs it is fed with, and it will apply an activation function to that sum. And they are connected to other neurons through synapses, so synaptic weights. And here we find the multiply and accumulate operations that I was discussing before, where a neuron is so performing the sum of the inputs weighted by the synaptic weights, so multiply and accumulate. And those systems usually are trained in a supervised manner with typically an algorithm that is called the backpropagation algorithm, but the idea is that you will present an input and you will get an output. So here you have several layers of neurons and synapses connecting everything together, and you will compare the output to the expected output. And based on the error between those two quantities, with the algorithm, you can define what should be the changes of each synaptic weight and so on in order to reduce the error in the future. But as we have seen in the previous presentation, nowadays those systems have millions or billions of parameters to change, to fetch, or computations that are related to those parameters. And we are still running those algorithms on von Neumann computers. So that's why, for example, for at least a decade now, industrials have tried to build and fabricate processors that are specialized for neural network applications. The main idea here is that most of them are based on pure CMOS, so silicon technology, like conventional computers. And in the very vast majority of them, learning on chip is actually kind of difficult, if that's feasible. Meaning that usually you need to perform the learning on a supercomputer off the chip, and then you upload the neural network, the trained neural network, onto the chip. So in the rest of my presentation, I will try to briefly introduce a few ideas that might be used to try to do those hardware more energy efficient. Okay. So first we will have a look at what's called spiking neural networks that are a bit closer to biology. And we will see how innovative memories can help addressing the need for highly integrable learning capable artificial synapses. And we will then see how, with two examples, how we can combine those technologies in order to produce more energy efficient hardware neural networks. So event-based computing, and that's closely related to what's called spiking neural networks, are systems that are going a bit further in mimicking the brains, biological brain, than a conventional deep neural network are doing, in the sense that they are using spiking neurons. So in the brain, your neurons are propagating action potentials, which are events. Basically, those are voltage pulses, and the amplitude of those pulses does not really matter. What matters, it's more the timing between pulses or their frequency rate and so on. And basically, a spiking neurons, what it does is that it integrates synaptic currents. And once it has integrated enough of those currents, it reaches a threshold and it will emit a spike itself. Okay. So an event at its output. And with those systems, you cannot really use the kind of algorithm that I've spoke about before, like the backpropagation one, but you can use other learning rules that are more inspired by biology, like for example, the spike timing dependent plasticity, STDP, that is a local and unsupervised learning rule, meaning that you need only the information directly around the synapse, here W, to be able to implement the learning rule rather than knowing the whole system like with backpropagation. So regarding STDP, if you consider a presynaptic neuron and a postsynaptic neuron connected through one synapse, and you look at a situation where you have two events, a presynaptic one and a postsynaptic one. You can have two situations. The first is that the postsynaptic events occurs after the presynaptic ones, meaning that it's likely that the presynaptic event was involved into triggering the postsynaptic one. In that case, you have causality between those two events, and the rule is to increase the synaptic weight. On the contrary, if you have no causality between those two events, meaning that the presynaptic occurs, for example, after the postsynaptic ones, we have no causality, and we will try to do the opposite, meaning decrease the synaptic weight. So those kind of rules and neurons and synapses have been around for now a few decades, and people have tried to implement those ones into silicon, CMOS chips in what's called neuromorphic systems. So here you can definitely build silicon spiking neurons, sorry. But when it comes to implementing CMOS synapses, it's a bit more difficult in the sense that usually those solutions requires a lot of area, of silicon areas, and that what's defined kind of the price of your chip. So we are facing the challenge of building integrable and learning capable artificial synapses for those kind of architectures. And that's where innovative nano devices like memory store might be or at least are a good candidate. So what are memory stores? So basically memory stores are something that were predicted in the 70s by Leon Xue, but were only experimentally found 15 years ago, let's say. Those are nano devices, so you are dealing with elements that have lateral dimension of a few dozens of nanometers. And the name literally means memory resistors, which means that those are programmable nano resistors, which is kind of, which is reminiscent of the behavior of biological synapses that we try to reproduce. I won't go into all the technical detail, but just know that there are several technologies that are competing regarding memory stores, but they all have some of kind of the same main features. So for example, if you look at the resistance versus the programming voltage for a ferroelectric memory store, you can see that you can reach different resistance values based on the programming voltage. Another interesting features of those devices is that if you apply repetitive identical programming pulses, you can gradually make the resistance of those devices to change, which is typically a learning process or something that we could use to implement a learning process. And how can we, how can memory store be helpful? It's actually twofold. First, they can help for the inference step of a neural network. Again, if we come back to the multiply and accumulate operation that we were discussing before, the idea here is to use the physics to do the computation for us. Okay, so how you do that? Basically, you build an electrical circuit that is like that one, where you present your inputs as voltages across memory stores. You encode the synaptic weight into the electrical conductance of those memory stores, which is 1 over the electrical resistance value, sorry. And at the end, you retrieve the summation of the current that is performed directly by Kirchhoff's law, and you get a current that is literally the result of the MAC operation between the voltage input and the conductance weight. Okay, and you can even go further by reproducing those kind of structure in a crossbar array of memory stores. Okay, so connecting lines and columns in that way, and at each intersection, at each interconnect, you have a memory store. And for example, that column here is actually that system. Okay, and the idea is that you can get something that helps you to do in an analog fashion a matrix by vector multiplication, so several and multiply and accumulate operation with something that is very dense. Okay, here we have something that is less than 1 or 2 micrometers wide. But memory store can also be helpful with the training phase. i.e. the learning, okay? So I won't go into many details, but just so that's the example for a ferroelectric memory store, but you will get kind of the same feature for all the other memory store technology. And the idea is that if you take a memory store and apply as a presynaptic or postsynaptic input or output, well-designed voltage waveforms with a given difference in time between those two, you can retrieve what's plotted on the right, where you have the conductance change versus the time difference between those two waveforms. You can have curves that are kind of reminiscent of the SPAC timing dependent plasticity learning rule that we were discussing before, but that's directly done in hardware, okay? You have no computation beyond the physics of the device that is involved here. So just to maybe be a bit more visual on that, here we are simulating a very simple neural network with one layer of input neuron, one layer of output neurons, and all-to-all connection between those ones. We are using the MNIST dataset, which is a very famous dataset for AI task of handwritten digits pictures that are 28 by 28 pixels. Yeah, and if you look at the maps of the synaptic values, so the synaptic weights, we have 100 output neurons, so we will have 100 of those small boxes here. And in each box, you will look at the synaptic weight of each of those synapses, and you will rearrange them in the same fashion as in the input pixel. So you have 28 by 28 pixels in every one of those boxes. And when you present the inputs in an unsupervised way, what you can see is that the system is gradually learning to recognize the handwritten digits. Okay, and yet we have a very simple system, and most of the computation is done by the physics of the device itself. So now that we have silicon spiking neurons, you can have memory store based synapse. And we have seen that, for example, moving data is expensive from the energy point of view. That's where comes the idea of trying to bring everything together in order to build, for example, intelligent sensors, where you would try to process the output of the sensor as soon as possible in order to minimize the overall energy consumption. So that's what is called nowadays edge computing. And we had the opportunity to try to do that in the European ULPEC project that was aiming at building an ultra-low power event-based camera. So in a nutshell, the idea was to take a special kind of camera that I will discuss just after and to co-integrate it onto the same silicon chip with a hardware neural network, spiking neural network, made of spiking neurons and ferroelectric memory-stive synapses. And the main information, the take-home message from that for that presentation related to the ULPEC project is, for example, that we were using an event-based camera, which is a kind of sensor that is inspired by biological retinas. And so they do not work like conventional cameras. So they are not frame-based. The idea is that, on the contrary, each pixel is working independently from the other, so in an asynchronous manner, and they only react to changes into their incoming illuminance. So regarding the light that they received, emitting events that might be positive or negative depending on if they saw an increase of light or a decrease of light. And otherwise, they do not produce any data. Okay, so that's what's represented here. That's the typical output of such a system, where in white and black you have the events, and in gray it means that you have no output for that pixel. And the main point of such a system for us, so if you're interested, just go have a look to those, follow those links, but I won't have time to show you the videos, for example. And here the ideas is that as you are detecting only changes, you will produce sparse data at the output of the system, which means that you will have less data to process or to transfer, resulting in a lower power consumption. Well, I will skip those 2 slides for the sake of time, but the idea is that we try to simulate neural networks that were using data produced by such a camera, and basically when we were using an STDP-like learning rule adapted to the hardware that we could build, we were not able to learn anything, and we had to go have a look at other learning rules in order to be able to retrieve some recognition rate that is represented on that axis. So for example, if you use a genuine STDP, you would be here with real world data. And with the learning rules that we implemented, you can actually retrieve what was the state of the art with the kind of system that we were using at that moment. But yeah, so that's about the idea of building edge computing systems with event-based cameras or event-based sensors, actually. But in the remaining time that I have, I would like to introduce another concept, another ideas that also make use of innovative memory devices, but that time to directly process radio frequency signals. Okay. So the idea is that we would be using what's called magnetic tunnel junctions, which are another type of nano device. If you want to have an idea of what it is, basically just think of 2 nanoscopic magnets, one of them which is fixed and the other that can have its magnetization that will rotate around 2 stable positions. And nowadays that technology is used to build magnetoresistive RAMs, which are a type of digital memory, for example, by Samsung. But those devices can have many more other uses. So for example, you can use them as what's called spin torque nano oscillators, where the idea is that you input a DC current into the device and you get a radio frequency signal, which the power depends on the input current. That is shown here in the experimental graph. And that kind of graph is actually very reminiscent of rectified linear units, which are one of the main activation function used nowadays in conventional artificial neural networks. So we have a nano neurons with a single device, but you can also use them as spin diodes, where you do the reverse. You inject a radio frequency power signal and you get a rectified voltage across the device that will be proportional to the power that you inject and to what's called the weight of the system, as shown here. And the idea is that with the same device, you can have both neurons and synapses. And you can combine those kind of nano synapses, for example, like here, where you will inject radio frequency signals at different frequencies that are matched to the resonant frequencies of those synapses. And if you look at the total rectified voltage, you get the multiply and accumulate operation. So that's what we observe here experimentally, where you have the experimental voltage that was measured in the lab by some of our collaborators versus the expected value. And you can see that we can perform, again, MAC operation on RF signal directly in our hardware. And just to conclude, so our collaborator used those ideas to build a very simple, fully spintronic neural network in hardware, where you have both the neurons and the synapses that are based on such a system. So right now it's kind of bulky, but the idea is that you can build multi-layer systems that are able to perform simple nonlinear classification task, represented here, where you have to, for example, discriminate between blue and red dots. So on top you have the simulation, at the bottom you have the experiment, and you can see that we have quite good agreement between those two. So that will be the last technical slide. The idea now is that you can think of going deeper and deeper with those architecture, trying to build deep radio frequency spintronic hardware neural networks. And when you do the prediction on what should the technology be based on the current literature, you might, you can expect energy gain that are 2 orders of magnitude compared to what current GPUs are doing, okay? So to conclude, first, obviously you need to, we need to address the elephant in the room, which is the energy sustainability of AI, okay? Event-based computing can be a good candidate, especially regarding the edge computing devices. CMOS is likely not to be enough to address all those issues, so that's why we might want to have a look towards or at unconventional and innovative nanoelectronic devices. We are still far from having industrial products based on those technologies. And in any case, our best, one of the best levers that we have here is to avoid producing data that we don't need to actually process or to transfer, okay? So there are things at the Bordeaux, French, and European level if you are interested into those questions. And thank you for your attention.
Thank you, Adrien, for all these thoughts and elements on how to build green AA and this work in progress. I'm sorry for the audience because we're a bit behind schedule, so we will, to preserve your brain time and your break time, we'll have a 10-minute break now until until noon and 5 minutes. There was a question about the rebound effect that Aurélie already started answering, and I think that's an excellent candidate for the panel discussion happening afterwards. Really, thanks a lot for your complimentary talks, Aurélie, Adrien, and I can say that we'll go to break time. Thanks a lot, everybody, and welcome back. In 10 minutes. To this workshop on green AI. So the final part of the workshop will be a panel discussion coordinated by Carli Fabre from the University of Bordeaux. So Carli Fabre, I'll just introduce you with a few words, Carli. Carli Fabre has spent more than 20 years developing and managing IT products, projects, and programs in both the public and private sectors, with a focus on developing analytical solutions that can improve the quality of decision-making. She's now the program manager at the University of Bordeaux for the ACT program, which aims at transforming the university in an experimental campus in order to tackle the societal and environmental challenges that we are facing. And this discussion will take place with Edward Curry, Adrien Vincent, and Aurélie Bugeau that you already have met and in the previous speeches. And we'll also welcoming to this discussion Karl Mason from the University of Galway. So I'll briefly introduce you, Karl Mason, as you are the new person in this panel discussion. So Dr. Karl Mason is a tenured lecturer above the bar, assistant professor in the School of Computer Science at the University of Galway. And he's an SFI Science Foundation Ireland funded principal investigator. His research focuses on developing artificial intelligence algorithms and applying them to various problem domains, for instance, renewable energy integration. He leads a team of 9 funded researchers within his research group at the University of Galway. Prior to his current appointment, Dr. Mason conducted his postdoctoral research at Cardiff University and the George Institute of Technology. He was nominated for the 2018 European AD PhD Dissertation Award and was awarded a Chalmers grant by the Royal Irish Academy in 2022. Welcome aboard, Karl. And I'll now leave the floor to yours, Carli, with this panel discussion, whose purpose and topic is how can we develop green AI, which is articulated around the three big questions that you are now all looking at in the slides.
Thank you, Sebastian. Yeah, so the panel discussion right now is the question that we're going to try to answer, or that we're going to discuss, is how we can develop green AI. And in order to be able to exchange on this question, we've identified three sub-questions. The first one is, what are we capable of doing today that can have a big impact on developing green AI that we're not doing? So something that is, in terms of technically speaking, something that is capable, but to be able to identify what's keeping us from doing it. The second question is about trying to identify what priorities we should set mid to long term in order to address what we're not capable of doing today, but that could have a big impact on how we advance towards developing green AI. And the last question is about looking to how we can develop and build partnerships in order to mutualize our resources and maximize the value of green AI. So those are the questions. So there was a couple of things, or lots of things, that were said this morning in the different talks that touch on some of these things, but this is an opportunity to go into more detail. So I open it up to the panel. If there's somebody that wants to take on the first question about what we're capable of doing today that can have a big impact on how we advance on the topic of green AI. Aurélie?
Yeah, I'm surprised by the question somehow. So you might not like my answer, but I'm gonna go into it. If we really want to have a big impact today, now we should take a break, stop developing things, take the time to think of what we want to do, and stop doing too many and training too many systems and everything. Well, this is not really innovation or anything, but yeah, the biggest impact we could have today, which is probably not long-term, but we need to take a step back.
And is there, because I mean, that's a legitimate response, but there's a reason why we don't do it. Is it something that is possible? Is there a way to bring people around being open to accepting that that's even an option?
No, it's not an option because of the economic world in which we are living, because of the rush we have and all this. So it's not really realistic, let's say. And but I think this would be the thing with the biggest impact. And so the other thing is really to think about what we are doing and which project, to think about the usage and the world we want to live in. But this is more the next question. So I'll leave that for later.
Is there somebody else on the panel?
Sure, I can jump in. Yeah, I definitely agree with that. And, I expect that as well, that it'll only get worse over time, given that size of these machine learning models are increasing. I would also say, though, say in Ireland, I have some figures for Ireland that, so EirGrid is the company that manages the transmission network and the kind of national grid in Ireland. And they released a report saying that data centers are expected to account for 28% of Ireland's electricity consumption by 2030. And, it doesn't really bode well, really. Just the amount of energy that's required for running these data centers, and of course training machine learning models is only part of this. Then the actual inference of these models also has a significant computational cost. So I think actually but that kind of points to an actual practical step that we could take right now. Well, I know I'm kind of jumping maybe to the second question a little bit, but something that we could do now would be to better integrate renewable energy into powering these data centers. I know that plenty of companies are looking at doing this, but that is something that could be done right now that would help to mitigate this issue a little bit.
And if I could just kind of drill down on that a little bit, because the focus here is on the processing of the data.
Okay,
but
sure.
is there not something that can be done that could have an impact? Because that was a little bit about what we heard in Edward's speech about being able to approach what data is collected that is necessary to be integrated into the use of AI, or that is applied in AI.
Yeah.
Is there not something that can be done around that to optimize about how to better identify what data needs to be collected, how it's stored, what kind of processing needs to be done, and how the data is used? That could perhaps not have as much of an impact as some of the other things, but that could come in.
I suspect that you probably would get some savings by doing things like that and being more mindful. And it's definitely something to consider. And also that there's and I think it was mentioned in some of the earlier talks today about the different computational requirements of the different models for training. So also that developing new algorithms with this in mind, I think would be one practical step that you could consider now.
Adrien, do you have a?
Yeah, just on that topic. So if we're focusing more on the use of AI to build and to find new solutions, I definitely agree with the concern that with the even bigger and bigger models, basically training those ones are only, it's only doable by the biggest players in the field, which means that the solutions that we will get from those systems will be highly biased in the direction that those players want to have. So that's one reason why we might want to try to build maybe smaller systems independently from their energy efficiency. And another interesting idea behind the AI systems, if you look at their use, is that, for example, if you take chess, where AI had a huge impact on how chess is played nowadays, because it allowed to explore solutions that were not considered at all by human players, because they did not follow the kind of principles that we were used to. But the AI-powered solution allowed to see that, okay, that might be something very strange in the first place, but when you look behind and try to dive into it, you might find a very interesting solution to a problem that has been around for hundreds of years. So in a research context, you might use AI to address those kind of problems, trying to give you new ideas that you might not have had as a human in the first place. Okay.
Edward, would you like
Yeah,
to?
if I could, I just a few minutes. I think the colleagues' contributions are very interesting. Like to me, I think the biggest thing we can do today is to try to look at the other disciplines, the people in particular domains that have these problems, and just to educate them that a little bit of AI, a little bit of machine learning can do an awful lot of wonderful things if it's applied correctly. So I absolutely agree with our large language models are gone a little bit out of control, but they're very much playthings. They're toys at this stage. No one's really considering using them in any real anger. So it's still an exploration of what's happening, but there's an awful lot of lessons that we're getting from them. And the lessons that we've gotten when we've tried to apply machine learning and AI for sustainability is that very, very simple data analysis can actually can have significant savings, can have significant improvement on the environment. So you don't always need the shiniest technology, the latest technology to actually start bringing the benefits that are there. So I think it's maybe a summary of a few of the points from the speakers, that if we can start educating our engineers, our energy engineers, our manufacturing engineers, if we can start educating other disciplines in the utility of data-driven approaches and data analytics, AI, machine learning, to solve problems and to optimize how they go about their day, I think there's an awful lot of benefit to be gotten there straight away without any more technology invention. Obviously, we want more technology invention because we want bigger steps forward, but I think there's an awful lot of potential on the table there that we can maximize today.
Aurélie?
Yeah, I completely agree with what was said by everyone. And also maybe, yeah, regarding this shining technology, we need, as has been showed, Adrien, mainly, we need new technology, we need new hardware that have less impacts. But we also need to be able to run models on old hardware, not to change them all the time, and especially for other disciplines and everything. The other thing is that I think we need more to discuss with sociology, philosophy researchers about, yeah, again, where we want to go, how we measure rebound effects, because I come back to that. How do we integrate them in the development of technology? And so I think we need to share experience with people really working on climate change and sustainability, but also with other disciplines.
Okay, but and some of those things that are that can be done, I won't say easily, but quickly, because it's not a technical solution, but there are also things that will take time. I mean, it's not necessarily easy to get somebody to change their views on something or to change their approach. Is there anything that is other than to stopping and taking the time to reflect? And do you think that this change in mixing the different disciplines and having this reflection about how to optimize what exists today, is that something that is, do you see that as something that is easily implemented, or that there's a lot of resistance? Because there's always this rush about, well, moving forward and not necessarily figuring out how to optimize what's in front of us. Is that something that is, for you, something that is easy to do or more difficult?
Just maybe to share, for instance, a thought on that. I was 2 days ago at a biology department meeting here in Bordeaux. And so they just discussed about that they bought a lot of servers because they had money for that to run AI, to run anything on biology. And so if you get the money, you don't know the impacts. If you get the money to buy things, because it's great to do AI, it's great to do new systems, this is how you get the money. I mean, we need to change a lot of things in the mentality and how it works, I think. So it's not easy. It's clearly not easy, given how it works. The research works now and society works now. I don't know.
And that's something that you mentioned during your talk, Aurélie. So for example, kind of forcing the reflection on people that are going to be buying equipment or buying different technologies that are going to be used within their research. Is that something that can be encouraged by, for example, defining new practices at the level of the institutions that are financing things like that? I mean, that's something that can be kind of like a trickle down policy that forces people to move in that direction.
Yeah, there should be policies, but they are difficult to take. I mean, it's difficult to say to researchers that well, we want you to do things differently. We don't want you to use the latest technology right now. We don't want you to have the brightest thing. I mean, we are tackling the freedom of researchers, I think, somehow. So I don't know, as a panel can answer that, but I think it's more complex than it seems, actually. But yeah, policies are necessary, sure.
Adrien?
Yeah, I kind of agree with Aurélie on that topic. I mean, you can see the problem at two levels. There is what researchers could do research on, with what means, and in that case, of course, you might want to try to prevent or to discard completely unreasonable tools that have a huge impact overall, but you might not want to miss important discoveries that are at that moment not energy efficient enough or have a significant impact because of a technological issue that might be solved 10 or 20 years later. Okay, but and in the second time, you also have, I mean, okay, you do research almost as free as you are used to do, but there is a question of defining which discoveries or innovation should should make it to the general public and into industry. I mean, so because you might have very nice techniques that have a tremendous impact that you do not want to go large scale. So I guess that's more at that level that we might want to have additional policies in order to try to make things a bit more sustainable in the long term.
Karl?
Hi, yeah. So just in terms of the question of, you know, rather than focusing on developing larger models, say, or do we optimize the current models that we have for, you know, greener AI? I think fundamentally, say like large companies like Google and Facebook, ultimately they're going to respond to economic incentives. I think this was already mentioned as well. So as long as it's financially cheaper to just develop larger models that are going to perform well, that's what they're going to do, you know. So you know, maybe the current cost of energy might make that slightly less economical, but fundamentally, I think that that's the path of least resistance for these companies, and that's really, and this is not to have a, you know, to be too critical, I guess, as to what they're doing, but that's fundamentally how they're going to work, is they'll just respond to incentives, you know.
But and that, so that can lead into the second question about, so what are the priorities to be set that could perhaps be put in place to tackle some of those challenges? Because there you're talking about changing policies that go beyond just what are being done at a level of an organization or institution or a business. That could be something that could be done in long term to develop new policies, to try to not regulate, but to frame the environment in a way that is not detrimental. But is there anything that can be done? What kind of priorities could be set?
Well, I think an economist would be in a better position to, you know, advise on this, but I guess that this does point towards what some of the other speakers were saying earlier, that, you know, this, for exactly these reasons, collaboration is what's important, you know, on this. And, you know, maybe that would be an interesting or an area where an economist might be able to provide some very valuable input in developing green AI, would be to looking at what you know, what policies will lead to you know, more sustainable you know, models and things like this.
For the other panelists, are there any priorities that could be set mid to long term? Something that perhaps we're not capable of doing today, but that is not very far off, that goes beyond what was already said? Because I have the feeling that so far, in terms of what can be done quickly, the list is rather short. So perhaps we by default go into mid to long term reflections, but is there anything else that you can add on to what that question? Adrien?
Yeah, maybe. I mean, it's an idea that has already been mentioned, I guess, by Aurélie, maybe in her talk. I would say that I would support the idea of thriving for reusability, like it has been kind of in the pipes for the EU regarding electronic products, but especially in the idea of those AI systems. So as already mentioned, we might want to build new systems that are more efficient and so on, but we also have to keep in mind how we could make those systems that they can be updated in time to implement newer models without having to rebuild it from scratch, because the fabrication process of those systems and in electronic system in general are very expensive, but they are also a huge impact. I mean, they are a huge part of their environmental impact, especially if you replace them on a short basis. So I guess that we might have policies trying to make it more economically interesting to go for trying to keep things running longer and being more easy to update or to repair. So that would be something that I don't see it happening in 18 months, but maybe in a few years.
Yeah, if I can complete with that, I think we need to invest more on recycling research also, how to recycle, because we don't know how to do it very well. It's or today, yeah, clearly much cheaper to buy new than to recycle. So this goes with the rest.
Edward?
Yeah, so I think for a medium term, I kind of go back to one of the ideas that I kind of gave in the talk, was this notion of shared data. And if you look at any AI project or data analytics project, anything from 40 to 80% of the cost of that project will be in preparing the data, cleaning the data, integrating it. It's the reason most projects fail, and why very few actually get to deployment, because of those challenges that exist in data. So even when we look at these large language models and the computational cost of them, I haven't seen much discussion about, well, how much data was collected, how much did it cost to store that, how long were you querying it for? So I think there's some significant indirect costs there as well. So I think it's important for us to be able to collectively collect more data and to be able to share it between us. And the example I give is I suppose something we might have all experienced. If you ever have a class of students and you have a project and you give them a data set, you say, here's a data set, and I'll explain the data set to you, and I want you to go away and come up with some ideas of how you can analyze that to extract some value from it. And almost every time I've done that, and I've done it a few times, same data set, and I've a pretty good idea of what's in there, but there's always somebody that comes along with something that I hadn't thought of, that I hadn't seen before. They've extracted some new kind of insight. So I think if we can make data more available, easier for people to be able to access, to be able to explore, I think we'll see more and more opportunities and more kind of creativity in trying to come up with solutions to our societal challenges by using data. So the more we can break down those barriers, I think the better the outcomes will be. And that's, thankfully, that is something that the Commission are seeing, as I say, to these common European data spaces. And as I say, that is a medium-term kind of goal. So if we can have that in place, and we can stimulate people to try to use AI to extract value from those data sets.
And just to ask you a question on that, because you mentioned that during your presentation, but how difficult is it going to be to get people from different sectors, for example, the public and private sectors, to accept and be willing to share data, to have trust in how the data is going to be used?
Yeah, absolutely. It depends. So each of those sectors will be quite different. The example I give you would be health. In the health scenario, you'll want extreme levels of trust individuals will only want to give their data to their practitioners, and maybe not all of their data. You know, the other extreme would be culture. So in the cultural space, you've got a lot of public organizations, and their mission is to share that data, to share that culture with everybody. So they'll want to disseminate it as widely as possible. So I think you'll see a spectrum of approaches. But also the notion of having kind of a data commons, or the ability to be able to contribute your data as an individual for a common good, I think is also something that we'll see as well. And we saw an example of that with COVID, where in Ireland we had a tracker app. That app would tell us what I suppose the movement of people and the reporting of cases, and that information was pooled on a voluntary basis centrally, so we can actually have a data resource that we could study and work with. So I think there's a range of models there. I think we need to figure out what trust models work best for what individuals, for what societies. But I suppose the Commission specifically with the data spaces, they're effectively allowing each of those sectors to try to define what this data governance or what these trust models should look like for their sector. So it's a combination of working with the communities, working with the organizations to identify what's acceptable to them. The one thing I would say is that not all data has to be made open. You know, it's a case of, well, can you improve the sharing of data? And then in certain instances where there's a benefit to making data open and to making it more accessible, to do it at that point as well.
Aurélie?
Yeah, there is a real challenge there, because it's much easier usually to buy your own sensors, do your own capture of data and then process them. So I agree that data must be made available and easily available and classified, so that it can be retrieved easily for each application. And maybe so this is more about education again, but maybe question every time you buy new things, to new sensors to acquire data, maybe question before, do I need this data? Do they exist somewhere else? Do I really need them? So this is again about education, and making data more accessible, and educate that it has an impact to buy sensors. Maybe those data exist, maybe they do not. If they do not, yeah, sure, buy your sensor and produce the data you need. But if they exist, maybe we use them, even if it's more difficult, and even if it takes more time often than doing from scratch, actually.
And do you think there's something to do there? Because you said that, for example, if the data that you want doesn't exist, that you purchase the capture so that you can collect the data, is there ever a case to where it's not 100% or it's not certain what data you need, and so there's this idea behind, well, let's just collect as much data as possible so that we have a short period of time we can ensure that we have the data that we need, and that we can process it afterwards. We can use what we identify later on that is necessary, and we can discard the rest, or we can share the rest so that somebody else can use that. Is that something else that could be taken into consideration in that reflection about?
Yes, we have this tendency of saying that the more data we have, the better our systems we train will be, the better things we can do. This is something we usually do. So I'm not sure I understand exactly how to answer your question. But
no, but it's not. Is because you talked earlier today in your talk about the impact. The impact versus the value. Are we able to identify the cost, the environmental cost of collecting all of the data, and the value that that data is going to give us in the end? Because
today I don't think we can. This is research that needs to be done. Actually, research on impacts still have to be done, because I don't think it's easy to answer this question.
Adrien?
Yeah, so actually I have two things that are related to things that were said. So for the very last topic, we could also imagine addressing the problem from the other side, meaning that nowadays system requires millions of examples, or I mean, a huge amount of data to be trained, but you have research topics that are about trying to perform learning with very fewer examples. I mean, typically the best example would be single shot learning, which is something that biological systems are able to perform. I mean, you only need once to be almost crushed by a truck to learn that you don't want to be near a truck on a road, and you do not have to repeat that a million times before knowing it, okay? So if we can also design systems that require significant less input data to be trained, we are also addressing that kind of issue. So that might be an alternative approach. And regarding the openness of data, I think that it exceeds the training data set. I mean, basically, for example, if we want to have something like making it mandatory to have a system impact analysis before being able to put a product on the market or developing a technology, currently we are lacking data about what are the industrial process required to build that kind of technology, what will be the impact in order to perform a precise and accurate life cycle assessment. So I guess we might also want to build open database about those kind of questions to be able to address those points.
Okay. Does anybody else on the panel want to answer or to comment on the second question before we move on to the third question? No? Okay, so the third question then is how we can build partnerships to mutualize our resources and maximize value. It's a very broad question. Is there anybody that wants to answer that? One of Edward Curry mentioned during his talk the notion of the data platform, the shared data platform, and so this is what you mentioned earlier is going to be necessary to build partnerships, to establish trust in both the data and also in the usage that is going to be applied to the data. Is there something that we can do to help facilitate the building of these partnerships?
Yeah, absolutely. So the data spaces that are currently there, the envisaged approach there is that each of those sectors, so the Commission has put together kind of proprietary actions to bring together the key stakeholders for each of those sectors that they've identified. And I think the unwritten wish or desire is that there would be partnerships that would form based on that, like the nucleus of a partnership to bring together sectoral actors to be able to share data and to work together. So I think like partnership would be a very important part of the data spaces, but it'll also be very important in terms of the use of AI across those data spaces as well. And within the talk I talked about specifically the European Partnership on AI Data and Robotics. So that's a public-private partnership with the European Commission that's bringing together those different communities in AI data and robotics with the Commission to basically define kind of a joint work program and joint investments in this area. And one of the things that they're specifically looking at are the societal challenges. How can AI and data be used and robotics be used to help solve those societal challenges? Now that's what I would describe as an institutional kind of partnership, a very high-level political partnership between companies and the government. But there's an awful lot more opportunities as well, more bottom-up kind of opportunities for partnerships as well. Like so everything from local companies in the city working together, or local stakeholders in the city working together on particular initiatives, right down to individuals, where individuals are contributing their data or analyzing the data that's been collected as well. So I think partnership will be the key, and I think there'll be lots of different types of partnerships that will be needed to kind of deliver on green AI and sustainable AI.
Anybody else have a remark on this question? Adrien.
Well, I guess that from a research point of view, any kind of action that would support collaborative work between researchers of different areas would be a nice thing, because if I take my personal case as an example, so for example, the 2 European projects that I had briefly mentioned in my presentation, so are involved people from very different fields trying to build something which is the unique, I mean, the main objective is to address AI, I mean, to build better hardware AI systems. And what we see during those collaborative projects is that people are working not the same language. Not everybody knows everything on the problem, so you really need to share the knowledge in order to build something that is better in the end. And a very practical example is that, for example, when we talk to, let's say, computer scientists, usually they have kind of small knowledge or little knowledge about the physical limitation or physical constraint of the systems that they are building from a software point of view. And when we are trying to explain to them that, well, we are building something very specialized that will not be able to do all that stuff, or the cost will be very high, I mean, it comes out of nowhere for them. And that's not, it doesn't have to be something difficult to understand. I mean, it's just that it's going through those collaborative works that we kind of build some shared knowledge about those common issues. And I guess that anything, fundings or conferences or workshop, like typically that one also, that would try to support those kind of knowledge spreading is a good thing for green AI. Okay.
Okay, thank you. So here, if you don't have any comments on these 3 questions, there are 2 questions that we received in the question and response. The first one is, if data for people recruitment is harnessed from the prominent companies, does it imply that the parameters for the recruitment process for these companies are biased, or if the programmer that regulates their parameters at the end is meant to be held responsible?
So I think I give that example. So I think it's a really good question. So the example that I gave was, I think the team that developed that system were not aware of the bias that was in the data. But I think the deeper question is do those companies have biased hiring processes? So even before the AI system came along, was the system for hiring people in those companies biased towards hiring more males and females? And then you can dive that back into, are we educating more males in computer science and in those technical subjects than we are females as well? So I think that there's a much deeper societal question there. Fundamentally, I think what we see is organizations are trying to improve their hiring processes to remove bias. So things like unconscious bias training and ensuring that hiring processes are open and are gender representative, and that they have, we'll say, appropriate EDI kind of approaches in them as well. So I personally, having looked at that example, I feel the AI system merely reflected the bias that existed in those organizations by looking at its data. And to change that, is it about the AI system needing to change, or the organization itself needing to change its processes to ensure that it actually had more fair hiring practices? Of course, that's my interpretation from the outside. I don't know the exact hiring processes of those companies, just as a caveat.
Okay, and then there's another question here that is for each of you. It says AI researchers should take their part in decisions. A question to our panelists: how do you see your roles in such a process? But I don't know if this is the continuation of a question. It says there's surely a question of prioritization of AI usage, which should be addressed on a political level. AI researchers should take their part in these decisions. Question to our panelists, how do you see your role in such a process? Aurélie?
Well, I think it's indeed our role to participate to discussion on policies. On my side, I'm starting to do that with the group Ecoinfo. We somehow are called to do that from in France at least. And again, I really think we need to exchange with political science, with economists, with sociology, with philosophy. All this is really important, not only to discuss usage, to discuss priority, to discuss the world we want to, because we don't know, there are many things we don't know how to do at sociology. We know we don't know many things about sociology. And yes, we need to take part in the definition of policies, as we, I think, discussed before. I mean, how much data, which hardware, which money, all this is really important.
Margaretha?
Thank you very much for a very interesting discussion. And I have a question about how to involve small and middle-sized companies. We have so far discussed quite a lot about large companies and large private partnership with private and university sector and so on. But I know that the European Commission is also interested in how to make smaller companies involved in digital transformation. And there are, for instance, these European digital innovation hubs. Are there some thoughts around how to reach out for those who are not so well equipped with resources?
Maybe I might take a first stab at that one. I think you've given a very good answer to your question. I think the European Digital Innovation Hubs are really a good response to be able to bring together the smaller companies within the ecosystems around those hubs to get them to participate in the projects. Within the kind of Horizon Europe projects, SME participation is encouraged. But we know that's difficult. A lot of smaller companies find it very difficult to work with the bureaucracy of those projects and to work with all the project meetings, and it can be challenging for them to work there. But I think the innovation hubs are definitely, I'd say, a more productive environment for them to work in. And from my point of view, all of these European Digital Innovation Hubs should have some data sets there. They should have some kind of data platform that the companies can use, can leverage, some kind of shared computational resources so that they don't have to each buy GPUs and the associated requirements for that. So I think they're a great opportunity to provide shared resources to the smaller players, and also to bring those players together so that they can start working together and developing partnerships, collaborations.
Thank you.
And I saw, Karl, you had your hand raised.
Yeah, I think actually that the idea of developing, green, let's say, energy efficient AI algorithms is actually, will have the largest impact on, SMEs that have, less resources. For instance, larger companies can just, throw a lot of computational resources and develop large models, and it's, they can afford to do that. But I actually think the development of more efficient algorithms and algorithms that can, be trained on less data with less computation will actually have the largest impact on these SMEs. So I think that actually, well, what can we do as researchers? I think that, having that as a priority when developing these methods would actually have the biggest impact on SMEs, because they are resource constrained. So I think that that's an action that, the research community could take.
Okay, I see that we have 1 minute left. Is there, for example, Adrien, did you want to comment on the question about what the role of researchers are in?
Well, I guess that a lot of things have already been discussed here. I mean, one remaining might be that where we are doing research, we are not taking political decisions that might come from politicians or normal people, let's say. So we might also have the need, or we might want to try to explain in the best possible way what are the results or the take-home messages of our research regarding those societal questions, because sometimes you have the feeling that a lot is lost in translation when the output of our research reaches the general public. So I don't know if it has to go through teaching or special kind of events or new ways to communicate with the general public. But I guess that would be one way to answer the questions. If more people are better informed, we might collectively go toward a better solution. So.
Okay. I see, Sebastian, that in terms of time, that we're out of time for the panel discussion.
Yes, thank you so much, Carli, and all the panelists for those lively discussion. Everything flowed just perfectly. It's really, really, really great. And good sign of it, I can't believe that we are almost 3 hours together, been together for 3 hours. I'll leave the final word to Charlotte, who is also at the University of Bordeaux. Charlotte is co-lead of the work package 3 of ENLIGHT DRIs on digital research infrastructures, and she's in charge of the AI strategy at the University of Bordeaux. So Charlotte, I'll leave you the final word.
Oh. Yeah. Thanks, Sebastian. And hi, everybody. I will briefly finish this workshop. To start, thanks for all the speakers for the quality of their presentation. There are obviously a lot of challenges. As Aurélie shows us, for now, artificial intelligence has a really strong environmental impact. Nevertheless, like we have seen during Adrien's presentation, some research projects are building a new AI, neuromorphic, which are less energy intensive, and I think it's a good reason to be optimistic. As we have discussed during the panel, this green AI is also a tool. It can bring some new solution. It can contribute to improve our ability to protect the planet, but it's all about balance. Building green AI is an important step to reduce our impact, but if we really want to have a positive impact, we have to use this green AI properly. Be focused on usage seems to be a good solution to merge the two questions of impact and value. I mean, it's not just about reducing our consumption of AI, it's about how to use it for the question which really matter. Because digital science is a wonderful tool to help us if it is responsibly built and used smartly. And I really hope you don't finish this workshop feeling too desperate, but on the contrary, confident about people and science and ready to take up the challenge. And for example, as Edward confirms, Europe already supports development of AI for sustainable development goals, and so support acceleration of discovery in this topic by boosting expert partnership and data exchange. So, on behalf of the ENLIGHT Consortium and the University of Bordeaux, I want to thank everyone for contributing to this workshop. Thanks to the speakers for share with us their knowledge. Thanks to the audience for all the questions, and a special thanks for my co-workers Magali and Sebastian. I really hope you had an interesting time, and if you want to know more about a European project in digital research, please note that another workshop will be organized next summer. The details about this workshop will be published in spring. Do not hesitate to email us if you have some question. Again, thank you all, and now I just wish you a really good day. Bye.